This lesson is about the trigonomic graphs of sine and cosine. Now, this is a different way of thinking than previous, so you're going to have to kind of switch the way your mind works a little bit, kind of be open-minded, think about your unit circle, going to have to recall some facts that you already know. Let's start with the sine graph. So, f of theta is the sine of theta. We're only thinking about sine. You know that the sine graph on your unit circle, or the sine part of the unit circle, is the y. Okay, that's the y-coordinate. So for now, we're only worried about the y-coordinate of our graph. Our y-axis then is the sine of theta, and our x-axis is the theta. That should make sense because f of theta, this middle thing, stands for our variable, so I'm labeling this part of my graph theta and this part sine of theta. That's what it represents. That's what y equals. Now, again, it's important that you realize that we're talking about the y part of our graph. We're going to label our y-axis for our highest and lowest point. So let's look at the unit circle. We know, looking at our y, our lowest point is 0. And we've got our middle point is 0, I should say. Our very lowest point is -1. Our very highest is 1. And all of these other values on the y are in between. So my highest point is 1. My lowest point is -1. Okay, in between that is 0. We talked yesterday when we talked about the Ferris wheel activity that's what my amplitude is. From that middle line to the furthest up point and my middle line to the furthest down point is my amplitude. So my amplitude here would be 1. Now, my period. How long does it take for this cycle to repeat? Well, how long does it take for the unit circle to repeat? To go around once and get every single value for y, it's going to take 2 pi. So we'll see that here in a second. We'll review that. But it takes one turn around the circle to get every single y. Let's start with 0 as our theta, and then let's make marks every pi over 6. So each one of these marks, I just kind of drew these lines in for you to be kind of a tickler. Just like if we drew an x and y axis, I might give you a coordinate grid. Let me show you one of those just to get you thinking. Like this. We don't always draw the full grid to be able to graph in coordinate plane graphing and ordinal graphing. Just like here, we won't always draw those midlines, but I've just done that just to give you a frame of reference. On this one, my first mark is pi over 6. The next would be pi over 3. The next would be pi over 2. And that's because I'm going by pi over 6. So yes, there is something happening between here and here, which is pi over 4. I'm not going to look at that for now. I'm just going to go by pi over 6. So pi over 2, 2 pi over 3, 5 pi over 6, and pi. And we're going to just start there. So, starting at when theta is 0. So when my angle is 0, my y value in my unit circle is also 0. So I can graph that. At pi over 6, my y value is 1/2. So I'm going to go ahead and go halfway up and put a mark there. At pi over 3, my value is square root of 3 over 2. If I plug square root of 3 over 2 in my calculator real quick, the approximation of that value is 0.87. So 0.87 is pretty close to 1, so I'm going to put a mark there. And when my angle is pi over 2, my sine, again just looking at that y value, is 1. I'm going to put a mark there. Now, when I come down, when I'm at 2 pi over 3, my y value is square root of 3 over 2. So we've already talked about where that would be located. When we go to 5 pi over 6, my y value is 1/2. At pi, my y value is 0. Okay, let's continue to go by pi over 6s. I'm not going to label them all, but maybe it would be a good idea to just kind of count them out with you. The next one would be 7 pi over 6. And at 7 pi over 6, my value is -1/2. So that's halfway down in the negative direction. At the next one, 4 pi over 3, my value would be negative square root of 3 over 2, which is -0.87. At 3 pi over 2, I'm at -1. And let's go ahead and label that just so we can get a good idea of where that is as far as a reference point. My next one would be 5 pi over 3. That would be at -0.87. The next pi over 6 value would be 11 pi over 6. That would be at -1/2. And when I got back to 2 pi, my value would be at 0. Now I'm going to go ahead and connect that as a smooth curve. I'm going to try to make sure it goes through every dot. So I had to get a little bit, fix that one just a little bit there. Okay. And that is one cycle all the way through. Now, we know that that's one cycle because here I go 1, and there's nothing that repeats itself yet. If I went on to the next pi over 6, which would be 11 pi over 6, 12 pi over 6, 13 pi over 6 would be my next value, it'd be 1/2 again. And so I would continue in this way. So I'm going to draw some dotted lines here. I'm going to go backwards with you here and just kind of illustrate what that would be. So if I go negative pi over 6, negative 2 pi over 3, negative pi over 2, let's do that. So from here I'm going to go negative pi over 6, that was negative 1/2. Negative 2 pi over 3, that'd be negative square root of 3 over 2. And negative pi over 2 would be negative 1. And I'm going to draw that dotted again because I really just want to show you one period here. And that it does begin to repeat if I start over again. Okay, so again, my period is 2 pi. That's how long does it take to repeat. Let's think about our domain. Remember, domain is x values, so what kind of x values could I get? Well, from left to right, I could get any angle I want, any angle as many times around the circle as I'd like. So my domain is from negative infinity to infinity. And my range is my highest y value, my lowest y value. My lowest is negative 1, my highest is 1. It does touch those, so I have a closed bracket, and there's my graph for that. The next part of what we need to talk about is our cosine graph. So what does the cosine graph look like? Very similar here. Let's go ahead and mark off some information that we know is going to come up. So we've got 1 is our highest value, negative 1 is our lowest value. We know that 1, 2, 3, n, that would be pi over 2. Again, going by pi over 6's. So pi over 6, pi over 3, pi over 2. And then let's skip to pi. 1, 2, 3, 3 pi over 2, and 2 pi, just to hit those major points. I'm not going to belabor that point again. My theta is my x-axis. My cosine of theta is my y-axis. Now don't get confused here. Remember, cosine on the unit circle is my x value. So I'm going to do that. I'm going to go backwards 3 and do negative pi over 2. And we're going to go ahead and begin to graph that. The cosine at 0 degrees, remember cosine's the x value, is 1. The cosine at pi over 6 is square root of 3 over 2, which is about 0.87. The cosine at pi over 3 is 1/2. The cosine at pi over 2 is 0. The cosine at 2 pi over 3 is negative 1/2. The cosine at 5 pi over 6 is negative square root of 3 over 2. And we continue on in that fashion. Hopefully you're seeing the pattern here. And as I go on through and go ahead and mark this up, hopefully you're getting these same values. You're seeing how this creates this pattern, this curve. Go ahead and connect those. And by the time I've done 2 pi, one full turn around the circle, I've arrived back at 1. So again, my period here is 2 pi. That's how long it takes to move through one time, one cycle. My amplitude from the middle line up to my highest or lowest point is 1. I can continue back this direction so that I can kind of make sure that you can see that there is some curvature there. And that goes that way, and here, this one goes that way. My domain, again, is from negative infinity to infinity, and my range is from negative 1 to 1. Again, that's my highest and lowest y value. Now, on the back side, I want to take some notes about some transformations. So those are your basic graphs. The best way I can compare that to you guys is you have known forever that y equals x is a line that goes straight through your graph like that. These are properties that you'll need to have in your brain and will eventually need to be memorized. These are the parent functions. Let's go ahead and start looking at the transformation. The general form is that y equals a sine of b times x minus c plus d. Now, the reason I'm giving you the general here is so that I can tell you what each piece does to transform this function. Any change in a, or a number in front of sine, gives you a vertical, stretch, or shrink. The easiest way to think about that in terms of what we talked about already was it changes the amplitude. If it's a stretch, that'd be a whole number like 3. If it's a shrink, that'd be a fraction like 1/3. Okay, and that would mean 3 and -3 are my highest and lowest. 1/3 and -1/3 are my highest and lowest. The next piece, b, something being multiplied by the argument, would be a horizontal stretch or shrink. Hopefully you remember back when we talked about transformations a long time ago with our other parent functions, that horizontal means opposite of what you think. So in this case, if it's a stretch, it's a half, and if it's a shrink, it's 2. This changes the period. This changes how often does it repeat itself. And we're going to talk more about that in a second. There's a special formula for that. This c, if it's plus or minus inside, that's a shift left or right. So that's inside of the parentheses. Remember, that's opposite what you think. So if it's negative, it's moving to the right. If it's positive, it's moving to the left. And finally, d, this one on the end, is a shift up or down. Remember, if it's positive, it's being shifted up, and if it's negative, it's being shifted down. To find the new period for sine and cosine, so this is just for sine and cosine. We'll talk about the different ones for the other trig functions when we cover those sections, is 2 pi divided by b. So you're going to take 2 pi, the normal period, and divide it by this right here, this b, and that will tell you what your new period is. That'll really help to get your midpoint, your starting point, and those in between. So we have 3 examples to look at before you start on your assignment. The first example is f of x equals sine of x. That's the normal one that we've already talked about. And g of x equals the sine of x over 3. Now, sine of x, we already know what that looks like. We just talked about that. Sine of x over 3. Well, what's happening here? Something is being multiplied by x. Another way that I could write that is it's sine of 1/3 x. So 1/3 would be a b, which means it changes my period. That's the only thing changing here. There's something being added or subtracted. The amplitude in front is still 1. So to see this change, we're going to do 2 pi divided by 1/3. Remember, when I divide by a fraction, that's the same as multiplying by its reciprocal. So 2 pi times 3 over 1 would be, put that over 1, 2 times 3 would be 6, so 6 pi over 1. And that's our new period. That's the only thing that's going to change here. Now let me show you what that looks like when we actually graph. I'm going to draw my x and y axis. I'm going to go by pi's in this case. This is just something you'll have to get used to deciding how to do this. I'm choosing to do that because I know that my final period is going to be 6 pi. My amplitudes did not change, so I've got 1 and -1. My sine, if I look at my original graph, my sine starts at 0. So if my sine starts at 0, I'm going to start my normal one at 0. I know that my normal period is 2 pi, so it's going to end after 2 pi, which means it'll go through this middle halfway through. So my f of x, my original graph, is going to look like this. And I'm going to completely go back and go through that all the way up until 6 pi, because that's what my new period is. Now, some of my lumps look a little bit higher than others. That's unintentional. That's just because I don't have a beautiful, perfect graph. But you kind of get the idea there. That's 3 cycles of that original one. That's my sine of x. The new graph, the g of x, it takes 6 pi to do 1 cycle, meaning it starts here, it ends here. The middle point would be 3 pi, right, because that's halfway between 0 and 6. And so my highest point would be halfway between that, which would be at 3 pi over 2, or 1.5 pi. My lowest point would be between 4 pi and 5 pi. And so if I connect that, there is my sine graph. And now I've graphed both pieces. Let's look at 2 more examples. I want to show you one with cosine and a different transformation. So example number 2 is f of x equals the cosine of x